Good afternoon, everyone. My name is Sambit Taraftar. I'm a recent postgraduate in immunology, and today I'm going to present my paper, which is Methods and Techniques of Production and the Environmental Impact of Biochar. It's a review paper. Okay, so um, here I have focused on the various pre-treatments that we do for the biochar making process. So it's so interesting to know that the developed countries actually produces lots of waste and generates lots of effluents and industrial waste. And what they do is they import these waste materials to developing countries like Vietnam, um, India, even, and Bangladesh, and all these countries. Even they used to import it to China, but certain laws have not allowed it to do so any further. So it becomes our burden to utilize or recycle uh, those waste from the from the developed countries, because uh, it is much more economically feasible for the developed nations to do that. So one of the ways where the organic waste that can be can be recycled into something useful is a biochar. Now, a biochar is a highly carbonaceous compound which has been made from pre-treating it and then uh, using pyrolysis to further make the biochar. Okay, so this is how biochar generally looks like. Like I said, it's a high carbon product made by pyrolyzing or degasifying an organic material at high temperatures. So, and in absence of oxygen, okay. Pyrolysis or thermal decomposition of plants and the derived materials are sorry, there is some background noise. So the pyrolysis happens and we generate CO2, we generate other fumes and gases. Okay, and biochar is said to consist of biomass, and it is very helpful for soil and water, um, for like I'm going to talk about applications now. Here I will say that some of the usefulness of these applications are in heavy metal removal. uh, we have used water hyacinth uh, and made it to biochar, and it is useful in taking out the arsenic that is there in the soil. It actually allows better nutrient absorption in the soil. Okay, it then also like promotes plant growth by the biochar that is produced. It is actually rich in potassium, so plants get a supply of potassium. And how the biochar does this is there are three or four types of processes. One of them is carbon sequestration. Then there is ion exchange. Then there is porations. Through these pores that are created, they the biochar actually um, helps to increase the fertility of the soil, the taking away of the heavy metals. Okay, decrease in soil bulk density. It also promotes water holding capacity. Okay, so right now I'm going to talk about the pre-treatment methods. So choosing the right pre-treatment method is essential because there are certain factors that must be kept in mind. One of them is the energy recovery capacity, where how much, if we optimize the biomass that is there to produce more of energy. So how can we produce more from a certain uh, amount of biomass and the maximum potential we can have? So from there we can actually see that what are the pre-treatment methods that we can implement. So let me talk about the different pre-treatment methods. So there are some physical pre-treatments that we do so that we increase the pore size. We granulate those and decrease the crystallinity that is there. So one of the process is the milling process. Milling is used to increase the cellulase accessibility of lignocellulose by altering their degree of crystallinity and altering the ultrastructure of the cellulose molecules. Okay, and then there is microwave irradiation. We take the biomass, we put it in a glass container, and we irradiate at around 2.3 kilowatts of microwave irradiation, which actually uh, increases the sorry, degrades the sugars that are present in there. Then also we use mechanical extrusion. Mechanical extrusion is used to uh, make the pieces much more smaller, decrease the crystallinity, and then we use pyrolysis method. In pyrolysis, uh, generally the temperatures is around 500 to 600, but there is also one more method of pyrolysis, that is torrefaction. Torrefaction uses temperatures of around uh, 140 to 300 degrees without the presence of oxygen. So this is a relatively slow temperature method, and it is generally used in pre-treatment methods. Then we have chemical pretreatments. And in chemical pretreatments, we use two types of pretreatments, that is the alkaline pretreatment method and the acidic pretreatment methods. So in alkaline pretreatment method, it is actually used because it is the chemicals like sodium hydroxide and potassium hydroxide are easily available and not as much costly, and also it's less corrosive in actual use. So what happens, there is one drawback to it, that the yield of say the how much we want the lignocellulose and the hemicellulose to be digested, or the other complex sugars, is not as good as in acidic pretreatment methods. So for acidic pretreatment methods, we generally use phosphoric acid, or we use the common acids also, H2SO4 or HCl. But the caveat of using acid is that acids are relatively costlier, and it is prone to corrosion, and safety issues are there. And also one more very uh, not so common, but it is there, that there are some inhibitory compounds like furfurals are produced when we use acidic pretreatment. So most of these pretreatments are done on bagasse, rice straw, these sort of uh, biomass which have a high quantity of lignocellulosic compounds and hemicellulosic compounds. So also there we use biological pretreatment methods. In biological pretreatment methods, we generally use enzymes that are produced from different fungi, like Seriporiopsis subverispora, Caiathus stricorius. These are actually relatively cheaper and not very dangerous to use also. And we can attain a good delignification process using these microorganisms. So I would like to conclude by saying that the biochar's physicochemical characteristics can be altered for environmental use by employing a variety of pretreatment strategies. The surface area and functional group of biochar can be modified with acids and alkalis. The biochar surface can be increased by modifying carbonaceous materials. And so when I was working in the lab with the with biochar production, we also did one uh, um, LCA test, that is the life cycle analysis test. And in that life cycle analysis test, we found that the has the this biochar has environmentally nominal impact on the present environment that's there. It Yeah. So due to its ability to improve soil quality and mitigate climate change, biochar is a promising tool for long-term environmental preservation. So thank you.